G'day and welcome back to part 3. Thought we'd start this video by having a look at the schematic, which I've completed the drawing of. I used a program called Design Spark to make an electronic version of this. I've been looking for a while for a package that would allow me to draw valve circuits, and tried this one by chance. It's by RS Electronics, or Radio Spares as they used to be known. It's designed as a tool to get customers designing circuits using their components and then give a nice easy way to order them. I had to give myself a bit of a crash course in creating new components, and once I'd done that I realised that all their library components were of a completely different scale to what I'd made the valves, so I ended up actually creating an entire new library. Every component you see is pretty much hand-drawn by me while I was learning how to do this, and I did it all in one sitting and suddenly realised it was 4:30 in the morning just as I was finishing this. So I actually quite enjoyed the process and completely lost track of time while I was doing it. As you can see, we have a nice electronic version of the circuit diagram here. For those of you that work with these older sets, there's no real surprises in here. The overall design of the circuit is quite common for its era. If we take a look at a Columbus set of a similar era, and this is a Model 25, then you'll see that there are some vast similarities between this set and the other one. And if you want to take a more in-depth look at the Model 25 schematic, I'll leave a link on the screen here. You can have a look at it on vintageradio.co.nz. Just one other thing that I've been thinking about and considering carefully as I go through this. The construction of the set is quite rough. And it's done my head in a little bit as to what I should do with that. And if you have a look at this picture here, you can see that I've rebuilt this particular cluster of connections, and I've used a piece of solid core wire that gives it some stiffness and just makes sure that it can't flop around or touch anything else. I really struggled with that as to whether I should put some tag strip in and tidy that up, but this is how the set was. If I go in and change that and make it tidy, it's no longer the set that it was. I find it hard to explain, and I hope you can understand what I'm trying to say. I'm going to leave the construction rough and untidy because that's how I found it, and I believe that that's probably how it was from factory. And if I start making a really nice tidy job of the inside of it, I'm taking away from some of its originality, and I don't want to do that. So whilst it's not the best construction and it's not the tidiest construction, it's the construction it had, and I want to leave that in there. If you disagree, please leave a comment down below and tell me why, but for now it's my intention to tidily, roughly replace the capacitors and leave the construction style much as I found it. Alright, hopefully you can see me enough to follow along here for a little bit. What I'm going to do is just replace a couple of capacitors in here, and you can follow along and watch the way I do it, which is not necessarily the correct way to do it, but it's the way I do it. If you disagree, that's what the comment section's for. So I'm going to try and get this one out and replaced. It looks like it's a 0.1, and it's in a really awkward spot. It's probably not necessary to go right where it is though, so we'll get this one out. Depending on how something's connected, I don't like to try and disentangle crimped wires, but nothing I've found in this set yet suggests that anybody tried to crimp anything. In fact, most of the connections are just blob soldered in place, and the fact that they've lasted 70 odd years or so is, yeah, what I tell you, is testament to the fact that solders actually provides a far better mechanical connection than a lot of people give it credit for. Which is no excuse for poor soldering or poor termination of component legs, but in this case it does show that while stuff is just sitting in place, and remember this chassis sits upside down, so it's had the benefit of gravity dragging these components down. The joints have not let go, or at least not obviously. This does look like old solder and old original connections, so I am going to re-terminate this just while I'm here, because while I want to keep things not original but in the original style, I do want to make sure that it's safe and generally speaking terminated in a fashion that will be lasting. And I may have mentioned this the other day, I'm using side cutters for everything at the moment because I can't find my little long nose pliers, so I'm just very carefully using those. Now, one thing to be really careful of with this particular style of valve socket, I'm just going to move everything out of the way, and hopefully you can see in there a tab with a hole in it that you can poke the components through. Now if you poke a component through that hole, there's a really good chance that if you're not careful, the end of the lead is going to go right through and touch the chassis, which is fine if that's an earth pin, but typically it's not going to be an earth pin, so just watch that. So got that in there. Now you may not be able to see this, but the end of this wire is in appalling condition, but it looks like just burnt flux. So I'm just going to try with some isopropyl alcohol to clean some of that off. The actual wire and the soldering tinning of the wire doesn't look too bad. And this crusty stuff is just flaking off. So I'm going to just trim the end of that, and I'm going to put that try and put it through the hole. I may not get the leg of the resistor through. So it was a 0.1 to ground. Now interestingly, with this component, the 0.1 mic cap ran from here right across to the tag over here, most likely because of the length of the capacitor itself. I think that we can actually just put a 0.1 in and whip it to the next pin. Not the next pin, but there's an earth tab off the screw terminal here, shielding one of the wires going to the volume control. So I can do a really short run with that straight to that pin, or I can bring it across and a little bit further run to an earth point just under here, which I think I'll do because it'll be a little bit tidier and a little bit easier to get to. So I'm going to try and do that in a way that makes it mechanically sound. That may be easier said than done. Unfortunately, what I'm trying to achieve is kind of get something under this resistor, which also needs to be in the way because it's part of that connection. Usual story. Stuff be in the way. So let's take that out of the way for the moment. I'm going to go back to this other earth terminal because it's going to be, I think, the tidiest way to do it. Use it to crimp that one down and then try and get that 25k screen grid resistor back in place. I'm going to tuck the end of this wire underneath that tag. It's not crimped, but it's firmly held in position. Now hopefully a lot of these braids suck the heat out really quick and you can't solder them. I've got the soldering iron turned up to a reasonable temperature. Of course the one that it does, it actually comes right off. Okay, so that's the braid on, that's that cap on. So I think that's the screen grid supply smoothing cap. And that's that one in place. Is it pretty? Nope. Is it prettier than it was? Yep. And as mentioned, that's what I'm aiming for at this particular point. Okay, so we've got a 0.05 here. Again, I've got some options as to where I actually take this, but let's get this out of the way. So that's the earth it came from. I of course do have this earth just down here, so I could come down to that one. This cap will be out of the way, and in fact what I'm going to do, because that cap being out of the way will just make that job a lot easier. So thanks again John for that tip. Clippy lead, that's where that component goes, and I've actually just clipped the component into place as you saw. That's going to help make that tidy. So I'm going to get this one out of the way. This is off the end of the volume control. That should be a 0.01. Don't know who made these or why, but I'm not a fan. I'm sure they were lovely 50 years ago. And I can forgive most cap manufacturers their sins, as long as they're not from Hunt's. Not a fan of Hunt's capacitors. That resistors, they didn't even poke the resistor through the hole on the tag strip. They just laid the lead against the side of it and soldered it in place. That's reasonably questionable. When you have a tag strip, you could at least use the damn thing. Although interestingly, as the solder's come off that, the tag strip itself looks like it wasn't possibly taking solder all that well. Yep, that'll do nicely. I'll put some heat shrink on. So this is what I mean about slightly ugly construction. I mean, that shouldn't be floating in the breeze like that. Even though this is floating and that's floating, they're not likely to touch unless someone actually pushes them together. And I'm certainly going to be careful to make sure that nothing else gets in the way. Now that I have that cleared out, I almost think the nicest way to do this one is just to put it back in where it was. I know there's great controversy around J-hooks and spirals or pigtails and various different means of connecting wires. I think it's all just teacup storms, to be fair. I don't subscribe to any one way being better than others. If you've got a mechanical connection, I mean, I see people do pigtails where they slide them on and, you know, you've got a 1/2 mil thick wire and almost 1.5 mil of hole inside the pigtail, and the wire's just flapping around in the breeze, and people will argue that that's better than a J-hook where the two J's are crimped against each other. It makes no sense to me. I think you use the connection that makes the best sense for what you're doing. I'm a big fan of using the right tool for the job, as opposed to being an advocate for a specific way of doing something every time. And in this situation, I am going to probably do a pigtail if I can get these pliers to do it for me, and I will be happy with that. And if you're not happy with that, well, comments are down there. Tell me all about it. Hopefully you can see there is a wee bit of a spiral there. That'll slip over. Now the thing that's going to hold these in position more firmly than just that little pigtail is I will crimp them. I'm not just going to leave the pigtail as it is. So give that wire a quick clean up because it's a bit grubby. So excuse my fingers. I probably do need to come up with some better camera angles if I'm going to expect you guys to sit and watch what I'm doing. Not that I expect you to sit and watch what I'm doing, but if you continue to watch my hands rather than what I'm trying to achieve, you're probably going to get a little bit annoyed eventually. Alright, so Just crimp those over, and that's now held in there pretty tight mechanically, and the solder just adds the cherry on the top. Done. Okay, so that's this area pretty much cleaned up. We've got a couple of mica caps in here. I'm not replacing those unless the set starts to develop particular silver mica disease type problems. That's this area done. I've got 2 caps to go. This is a bypass off the 6U7. I think, like the other one, what I'll do just for simplicity, and I suspect this has been, I don't know about the resistor, they may have reused that, but the cap I'm pretty sure has definitely been, I'm definitely almost certain that it's been replaced. So we can put one straight across there in a really short, nice, neat hop. That is 0.1 and a 500 ohm resistor. Okay, that's good. Okay, so that one was the cathode bypass for the 6A8. Also a 0.1. It's going to be awkward because the aerial coil's kind of in the way as well. So there's one more cap on the top side we need to do. Now, one thing, I did get a comment from Yarraman about the 0.01 that I threw in here just as a try, and he seemed to think that it should be a 0.005, which would be a 472, which I do not have. But I do have spare 0.01s rather. So if we stick a couple of those in series, it should give us a 0.005. The other alternative is that I leave this one in and put it to ground, kind of the typical setup that you see on other sets, including the Model 84 that I showed before. And I'm just going to tack this in because I don't necessarily know that this is what we're going to use. That's sitting easily where I can just push down on it with something and make contact. So that's 2.01s. When you series capacitors, you halve the value. So that's 0.005. We'll see whether that sounds significantly different. Just taking the earth off here, and as I heated it up, basically the whole thing just fell off there, so that should give you some indication of just how viable that particular point was as an earth. Now, it was probably connected fine, but would I trust it as an earth, particularly as a mains earth? Absolutely not. So we'll need to find a better earth than that. Well, I think the best position to come to really is this earth down here where the 2 caps are. So I'm going to have quite a long tail of earth out of my power cord here. So I'm just going to have a look for a cable clamp. So I do have some of these compression style cable clamps, and they are not bad, but they really require an oval shaped hole to work. I don't know how well you can see that in the camera, but they have flat sides which stops them from spinning. And as I don't have any easy way of creating an oval shaped hole, I'm not going to use one of those. What I probably will use is something like this, where it basically just requires one hole in the chassis, and it uses the strength of the bent metal itself just to hold its shape and hold the cable against the side of the chassis. We'll put some heat shrink over where that's going to be just to protect the sheathing on the wire. And I'll probably put another piece where it goes through the grommet just to tidy that up a little bit. Okay, so that's done. Clamped here, I've got a bit of heat shrink there, and if I pull on that, it's nice and tight. If I twist it, it can't twist beyond the minimal twisting of this short section here. No, that doesn't look like original, so that kind of goes against what I said about what I was doing with the rest of the set. This is a human interfacing piece of kit, the power cord, so I'm not going to be the only owner of this set. I imagine it's going to end up in someone else's hands at some point, and so things like the power cord I want to be nice and safe. So just move you over to where the switch is here. So we're going to pull this apart and see if we can clean up the contacts, because the action is a little bit sloppy. The switch contacts did not seem to be completely 0 ohms when closed, so I'm not convinced that they're in 100% tidy condition inside the housing of the switch. The switch is riveted together, and I do have some rivets, but I don't think they're going to be the right size to actually be able to close this up again, so we may be looking at other possibilities there. But for now, we'll get that out. I'll clean up the bench a little bit, we'll pull that apart and see if we can just do something with the contacts, and then we'll work out how on earth we're going to put it back together later. And if we can't, well, I mean, we can. We'll find a way. There's always a way. So we'll get that out next and have a look at it, and we'll worry about fusing this later, since those fuse holders that I've got seem to have disappeared into the abyss, which is the garage. Alright, so here's the on-off switch that we've got. As you may be able to see here, there's some little brass rivets pounded through and then just staked out on the other side. And the only way we're going to get that apart, I think, is to drill these out and then push the rivets out. I don't think there'll be enough left to in any way restake those once we're done. But what we'll do is we'll get these wires off, we'll drill those out and we'll pull it apart and have a look and see what we've got in the way of rivets or small bolts to try and put this back together again once we're done. Interestingly, there were 3 star washers on the back of this. Now I don't know if that was just to avoid taking a small portion off the end of the shaft to get it to sit at the right length, or if it was trying to be spaced off the chassis, or what they were trying to achieve there. But that may give us a little bit of wiggle room if we have to put screws in here for the head of the screw or the machine bolt to sit. Now, again, I don't know if I've got anything fine enough and long enough to do that, but we'll get it apart first and then we'll figure out what we're doing afterwards. Just a point on these Cliffie leads, and I'll pull one of these apart just to show you what I'm talking about. I buy these in lots of 10. They look big and beefy and chunky. You can't even tell where the wire is. It's certainly not soldered. All they do is they strip the wire, they fold it back under the insulation and then crimp this into position. I don't know if it'll focus down well enough to actually show you, but the wire in this one is actually poking up through that gap in the side, so it's not even crushed down onto the metal. So what I normally do when I get these is I take that crimp apart, re-terminate the wire and solder it, and then put the crimp back down, so that I know I have nice complete contact Cliffie leads. Right, so I just thought I'd see if I can do this on camera, and hopefully you'll be able to see what I'm doing. I guess I'm just going to try and clean these contacts on camera. I've got some isopropyl alcohol, which is worth its weight in gold at the moment, but its main use to me is in electronics. And just try and clean that contact off, and you can see the cotton bud's getting a wee bit dirty. That's looking pretty clean in there. I am actually going to touch that up a little bit with a slightly more aggressive clean off camera, but that's made a huge difference. Right. So had a look around and I found an old box of panel pins here. These are pretty close. That's a nice snug fit through there. What I'm going to have to do is just go and cut these off with some snippers and try and pin it over as best I can. Seems to be working. I want to put a terminal strip on the side here to connect those rather than just have them floating. If that was bolted there, and we put one side there, one side there, I think that's going to be the tidiest way to do it. So we'll get this working, and then I think we'll call it the end of part 3, eh? Phase can come into this end terminal, and then I can run a wire to the switch. The other side of the wire can come back and onto one side of the transformer primary. Neutral can come back here to the other side of the transformer primary, so that's my switched primary. earth can come onto here, which will now be a nice neat earth soldered direct to the tag strip. No, I'm going to run the earth over to here because that is the main earth point. Alright, so one of the places I like to get decent wire with decent insulation is old computer power supplies. The wire from electronics hobby stores, if you can find any anymore. In New Zealand we're pretty much down to J-car, although in Christchurch there is South Island Components as well, or at least last time I checked they were there. I'm not aware of any others. Yeah, certainly the days of electronics stores on every corner are long gone. The longest time we had David Reed, and if you're Australian you may or may not recognise them. I actually was shown a post on it was a post from a long time ago about a David Reed store that was in, I think, Sydney. And one of the contributors to that post was one David L. Jones from way back in the day, saying that he remembered that store. David Jones, for those who don't recognise the name, otherwise known as that crazy Aussie bloke, is EEV Blog now, which is a very popular electronics engineering channel on YouTube, one that I quite enjoy watching. So there was a David Reed in Australia apparently at one time. I'd be very surprised if it's still there, but they were everywhere in New Zealand. Started in Auckland. David Reed was a well-known figure in the early electronics and radio industry in New Zealand. Started his own store selling parts, became a chain of stores. Dick Smith came along from Australia, bought them, and all our David Reeds disappeared and became Dick Smiths, to the best of my recollection. I do remember when we had David Reeds, but I actually worked for Dick Smith as an after-school job many years ago, after David Reed had gone. Still remember some of the antics we got up to in that store. I remember my offsider that worked there with me demonstrating a multimeter and showing the customer how he could measure the voltage from a mains plug. He had it switched to ohms at the time. I don't know if you've ever tried that. Please don't try that. There was an earth-shattering kaboom, a cloud of green haze that hung over the shop for a while. No probes left. The meter didn't work anymore. And when the smoke cleared, the customer had gone as well, never to be seen again. That was not a sale he got. Measuring the impedance of the national grid, not something your average basic multimeter is up to. Young boys left in charge of an electronics shop. We had a great time. Fond memories. Just a hint with this heat shrink. I don't know if you'll be able to see this, the word tube on the side of there. Heat shrink, modern heat shrink tends to have writing on it giving you the size and the specs and manufacturer. And I just think it's tidier, if you can, to rotate that into a hidden position so that when it's shrunk down it's just tube. Now, you can't always do that, but it's just one of those things I try and do, just to try and get things looking neat. Right, so that's taken quite well, terminated nicely. Alright, so at this point what we've got is a set which has been fully recapped. A couple of the resistors have been replaced. I've spot checked a few others, I didn't fully check them. I've tidied up a couple of the hideous junctions. I mean, this one's not pretty, but it's really stiff and firm. This one was awful. There's another couple that were awful that have been just replaced because the components were all replaced with smaller, tidier components that could be fitted in a little bit easier. But generally speaking, it's all tidier than it was, but in the same style. And that was, as I mentioned, what I was going for. So Next step, I'm just going to look for any blobs of solder. I'm going to flip this set over and give it a wee bit of a knockout just to try and get any loose bits from the inside of the set out onto the bench. Then we're going to plug it into the dim bulb tester. I'll move the camera again so that you can see what's going on, and we'll fire it up, make sure it's still working. If it's still working, then it's clean up time, and then we're onto the cabinet. Unit set to via bulb and it's turned off. That's switched on, or plugged in rather. Nothing. And that's pretty much what we'd expect to see, which is good. That is much dimmer in its dim point, I think, than what we were seeing before. So remember, there's going to be a wee bit of noise at this bench.
Still have to pay the interest on that, and the principal obviously at a later date after 6 months. So I think there might need to be further measures around those areas.
So that noise is not ideal.
We can toggle back on the economy and can gradually turn the economy back on.
I still can't shut that right down, so we need to have a look at why that is.
Our IF signal comes out of here. These diodes detect the signal out. The audio signal being detected out is fed down through here to ground and is tapped off this 500k volume control and fed back into the audio amplification stage of this 6B8. My immediate suspicion is possibly a faulty volume control and that this wiper is not actually getting all the way to ground. This has been replaced. These two have been replaced. I'll check the 50k, the 500k. From memory, that 100 pick cap is a Hunt's. I should have a 100 pick capacitor that I can just replace that with if I need to. That is the 100 pick cap and the 500k resistor there. My first act is going to be to measure the volume control. 443, that's pretty good. Right, wipe it to ground. It should be fully volumed down now. Right, we're looking at about 3.5k, which out of 500k might not seem like a lot, but that should be a lot lower than that. So it could very well be the volume control. So let me find Cliffie lead. Alright, so I've Cliffie leaded the wiper to ground. Alright, that's good. Right, let's see if that has solved our problem. And I got nothing. Silence is golden. Okay, so I'd love to blame the Hunt's capacitor, but in this case the volume control is the offending article. But I think it's Bakelite, but it's almost like they've put crayon or something in it. It's a really lovely coloured body. I've never seen one like that. I haven't seen one of these before. They're an unusual style of resistor. You certainly, well, I don't believe you see them today. I'm just going to see if I can get some light on this. The joys of working in the ridiculous hours. This wiper over here is pushing this metal band, which is connected to the center pin, or the wiper as such, and as it goes round it's pushing that central band out onto the rim, and on the rim is where the resistance portion is. So for whatever reason that's unable to get it to contact low enough when the volume is at this end. It does actually, and it's going to be a little bit hard to see, but it does look like there's a little kink in that band right down the bottom end, but the wiper doesn't go fully onto the metal tab at the end there. So I might just see if I can give that a little tweak. It'll be interesting to see if I can get this out of here. And we're out. Okay, so with the ring removed, you may or may not be able to see the carbon track tapers off visually towards the end here, and there is what looks like kind of a wet smudge. So I'm going to try and very carefully clean just here, because the volume control is not scratchy, it's not causing any issues other than just not shutting down. So it'd be a shame to bin it for no reason. So it's got a little tiny bit of IPA on here. There's a little bit of dirt coming off it. Dirt or carbon. See, there's a wee bit of carbon come off on the end of that cotton bud. The other part of the problem could be, as I say, this is not round. It's probably spent a lot of its time in this area, which is actually the low volume area, which is where I'm guessing most radios run. So little blobs and bits and pieces of carbon on this wiper. But we'll just try and take that bend out without, it's quite supple. So at the bottom end we now have still 3K. Well, that's disappointing. I found an old Tessa brand, which is actually, I don't know where Tessa's from, but I know that was sold here in New Zealand. Direct imports. Rings a bell. So I just wanted to take the cap off and have a look at the inside, because it's pretty grubby on the outside. It is a second hand one. It feels nice and smooth. So I just wanted to have a quick check and see what it was like. Shaft is bang on the right length, so that's good. If you can see, there's a circlip that holds that shaft in. I'm just going to go into the gap between the circlip and put the barest dot of machine oil. It will work its way down into the shaft and it will free up. That's feeling really nice. And this can go back together and we'll give it a go. Yep, nothing going wrong there. Back to direct.
You've got Warriors obviously staying awkward, and they all go live in the town, and then competition carries on. And I contract to Sky Television, mate, and I'll tell you what, I've got a lot of people out there that are worried about their jobs. We don't know what's going to happen.
Okay, so that's working pretty well. Volume control's clean, it's not scratchy, it's working fine.
Quiet, plus zero corona.
So I'm happy with that. There's nothing else I think needs changing or tidying up in here at the moment. What I'm going to do now is do a quick test of that tone cap arrangement that we've got in there. It's set up with a couple of 0.01s in series, which should give us 0.005. As I mentioned, if you have a look in the comments from the first or second video, there's a comment from Yarraman about the fact that should probably be a 0.005. So I tested 0.01. It actually took probably what I would consider too much of the top end away. So it's going to be interesting to see what a 0.005 does. So we'll give that a bill. See what it's like with audio, and then we'll see if we can find some music with some speech. We'll see if we can find some music and see what it does to that.
Oh, good morning. I've got a well-balanced pot. Oh, before I carry on, you've got to wish me happy birthday today.
Happy birthday, Sue. How young are you today?
36 years sober.
You're fantastic, because I was going to say, you don't sound, are you not 36? Yeah, you're going to tell me a
Right,
bit
so
later.
that doesn't seem to be making a lot of difference to audio. If anything, that sounds to me to be lifting the tone. So that's interesting. To me, and it's probably hard to tell on camera, but to me that actually sounds like it's lifting the tone, improving the high end rather than cutting it in the way that the 0.01 was. So I prefer that effect. If I'm not going to have a tone control in a set, I'd rather it was bright. Yeah, 0.05 I think is what we're going to go with. I don't have, like I said, I don't have a 0.005 cap in a 1000 volt rating, so I will just attach these two caps together. Okay, so at this point I'm done with underneath. We've got a working set that's going to sit something like that. With that like that, I can see why they've had to dish that chassis in, because that's going to be pretty close to touching, I think. I suspect that all you're going to see is just a slight glow in the top, but that's the effect that the designers are going for, is to get that ink to glow with the light shining through the center of the glass. So when you hear someone talking about an edge lit dial, that's pretty much what they mean. Okay, well, that's going to be it for part 3. So thanks for watching. Catch you in part 4.